Your Majesty, Your Royal Highness, ladies and gentlemen, the Academy of Science has resolved to award the Nobel Prize in Physics for 1930 to Sir Venkataraman for his work on the scattering of light and the discovery of the effect named after him. The diffusion of light is an optical phenomenon which has been known for a long time. A ray of light is not perceptible unless it strikes for the eye directly. If, however, a bundle of rays of light traverses a medium in which extremely fine dust is present, the ray of light will scatter on the sides and the part of the pale through particles of dust begin to oscillate owing to electric influences from the ray of light and they from centers from which light is disseminated in all directions. The wavelength of the number of oscillations per second in the light tubes diffused is the same in original way in the light, but this effect has different degrees of strength for light with different is stronger for the short than for long ones, and consequently it is stronger for the blue part of the spectrum for the red part. Hence, if the ray light containing all the colors of the spectrum passes through the medium, yellow and red rays will pass through the medium without appreciable scattering, whereas the blue rays will be scattered to the sides. This effect has received the name of Tyndall effect. So, who has made a study of this effect has put forward the hypothesis that the blue colors of the sky and the reddish coloring that is observed at sunrise and also the sunset is caused by diffusion of light owing for the fine dust of the particle of water in the atmosphere. The blue light from the sky would thus be atmosphere and which has become improved in the blue weight owing to scattering later in about 2000 throughout the suggestion that the phenomenon in question might be due to the fact the molecules of air themselves exercise a scatter HI phase of light, but a closer examination of scattering in different substances in solid, liquid, or gas from show that the scarlet light did not certain respects exactly follow the Bloch which, according to the calculation, should hold good a Tyndall effect. The hypothesis which from the basis of effect would be same the include, amongst other things, the rays scattered to the sides were polar. This, however, did not prove to be exactly the case, so this divergence from the what's expected was my starting point. Searching study of the nature scattering light, in which study Raman of the who took an active part. So, in order study more closely the properties of the new light, the primary light that was emitted from a powerful mercury lamp was fired in such a way yield in a primary light of the one wavelength. The light scattered from the ray in the medium was watched in a spectrum in which wavelength or frequency reduced a light. And here he found that in addition to mercury light chosen, there was often a spectrum of a strap lights which appeared the spectrum on other side in the original light. When another mercury light was employed, the same extra spectrum saw itself broadened. Thus, when the primary light was removed, the new spectrum followed. In such way of the frequency, distance between the primary light and the nucleus always remain the same. the explanation of phenomenon, which was received the name of Raman effect, as its discovery has been found by Raman himself with the help of the modern conception of the nature of light. According to the conception, light cannot be emitted or absorbed by material otherwise than in the defined amount of energy what known like light quanta. Thus the energy of light would both a kind of main character. A quantum light is the frequency the break light. So that is the case of frequency drives as ray, the quanta the rays of light be drives as ray. Only certain parts are suitable. When the electron moves in such path, no energy is emitted. When, on the other hand, an electron falls into the pathway, higher energy to one with low energy, that is to say, from the other part, light is emitted with frequency that is characteristic in the size of two parts. And the energy of radiation consists of quantum of light. Thus, the atom can be rise many things as the number different transitions between the stable part, but an incoming radiation cannot be absorbed by atom unless the light is quantum is identical with the one of the light quanta that the atom can emit. So the Royal Academy of Science has awarded the Nobel Prize in Physics for your entire research of the diffusion of gases and your discovery of the effect that bears your name. The Raman effect has opened the road of your knowledge. The structure of matter has already given modern research and now has received prize for the hands of His Majesty. Thank you so much.